All right, so for today's lesson, the idea is we're going to be solving multi-step linear equations. So the do now is without solving the equations, explain in words why the following equations have the same solution. So take a look at this first one, right? 2x over 3 plus 2 equals to 10. And then take a look at the second one, 2x plus 6 equals 30. Do you see how they possibly could have gotten from yellow to green? Hopefully you realize that if you were to multiply this first equation by 3 and do math, 3 divided by 3 is 1. 1 times 2x is 2x. That was that piece. 3 divided by 1 is 3 times 2 is 6. And then 3 divided by 1 is 3 times 10 is 30. So those first two equations, yellow and green, are equal because you can actually multiply the first equation by 3 to get the second. So we're going to write that. You can multiply the first equation by 3 to get the second. Well, now we have this third equation in play, and we're trying to figure out, well, how do we now get to 8x plus 24 equals 120? There's a couple ways that you could actually do that. One of them is if you go from green to yellow, notice how from green to yellow, if I multiply everything through by 4, 2 times 4 is 8, 6 times 4 is 24, 30 times 4 is 120, I can get from green to yellow. You can also go from, green to blue. You can also go from yellow to blue by realizing, well, if you multiply everything in yellow by 12 and do math, that's going to also get you to blue. 12 divided by 3 is 3. 3 times 2x. 12 divided by 3 is 4. Keep messing up, I apologize. 4 times 2x is 8x. 12 divided by 1 is 12 times 2 is 24. And then there's your 12 times 110. So without solving, you can figure out that these equations are all equivalent. So I'm going to actually go from green to blue, and I'm going to say and we could go from yellow also, but you can go from the second equation to the third by multiplying by 4. So the idea is just to realize that those are all equivalent equations. Alrighty. The second do now is basically to solve and check this particular equation. Understanding that you do, in fact, have the distributive property, which has to happen on the right-hand side. So what's not being touched is 17 equals 5x. What is being touched is the distributive property, negative 4x plus 12, distributing in negative 4. Then hopefully you see that I've got like terms on the right-hand side. I need to do that. So on the right-hand side, that's just 1x. I never use the plus 12 and never use the 17. All that's left to do is subtract 12 on both sides and get 5 equaling x. When they ask you to check the equation, the idea is they want you to substitute in the value that you got for x into x and then do the math. So your check could look something like this. Does 17 equal, question mark equal, does 17 equal 5 times x minus 4 x minus 3? Remember, we found out the x was 5, so I need to put in a 5 wherever I see an x. So if I start doing some math, it turns out that I'm going to get 17. Does it equal? This becomes 25. Of course, I forgot what I wrote here. This becomes minus 4 times parentheses 2. And then does 17 equal 25 minus 8? And you know what? It does. So my answer that I got, being x equals 5, happens to be the right answer. So now we start getting into the next stuff where we say, you know what? There's lots of different ways to solve equations. It doesn't necessarily matter where you start. You can do whatever you want. Okay, so you learned maybe last year that always bring the x's to the left, or always bring the x's to the side that have the most. It doesn't matter. The idea is that we should have the same answer in the end. Our processes might be different, and that's okay. So one way to solve this particular equation, 3x plus 4 equals 8x minus 16, is we could bring all the variables, I'm going to call them x's, bring all the x's to the left-hand side of the equation, then all the constants, the numbers that don't have x, to the right. That's one way to solve it. Somebody might say, well, wait a second. I want to bring the x's to the right first. And if I bring x's to the right, then I have to bring constants, numbers that don't have x's, to the left. That's how they wanted to solve it. And somebody else says, well, I don't want to do any of that. I want to start with my constants, my numbers. So I want to bring constants, numbers, right first. Then I'll bring my x's left. And somebody else might say, okay, well, I'm doing it different from all of you. I want to bring my constants to the left first, and then I want to bring x's to the right. Again, it doesn't matter what you choose to do. You got to do something. Either way, all four ways, we all are going to get the same answer. So let's start off with the way one. So way one, we've got 3x plus 4 equals 8x minus 16. Well, if I'm going to bring my x's to the left, I'm going to be subtracting 8x from both sides. I'm going to end up with negative 5x plus 4 equals negative 16. I'm now going to bring my constants over to my right. I'm going to subtract 4 from both sides, and I'm going to get negative 5x equals negative 20. I now have to divide both sides by negative 5, and I get x equals positive 4. It should be no different than if you bring the x's to the right. So if I were to do it this way, 3x plus 4 equals 8x minus 16. Well, I'm going to go x's to the right. Okay, so subtract 3x from both sides. You're left with 4 equals 5x minus 16. If x's go right, without x goes left. Add 16 to both sides. 20 equals 5x. Running out of room, divide both sides by 5, and you still get 4 equal to x. It doesn't matter. Let's bring this down and do the other two ways real fast. I know it seems kind of monotonous, but it's important that you see that it doesn't matter what you do. Here, if we start the equation, and again, if you think you want to fast forward from this point to the next page, that's okay. So here we're saying bring numbers to the right, which means I'm going to subtract 4 first. 3x equals 8x minus 20. If numbers go right, letters go left. Subtract 8x, negative 5x, negative 20. Divide by negative 5, and once again, we already knew this, x was 4. Last but not least, we start off the same. 3x plus 4 equals 8x minus 16. And this time we're actually going to bring our numbers to the left. So I'm going to start off, I think I did that on the, oh no, that's right. Okay, so I'm going to add 16 to both sides. I almost got myself a little confused. 3x plus 20 equals 8x. I'm going to bring my letters to the right, subtract 3x, and then we get 20 equals 5x. Divide both sides by 5. Again, the idea to take away from this is that you can start solving your equation however you want. Okay? You either are going to bring, didn't give me the full page, you're either going to bring the letters over one side first and numbers to the opposite side, or you're going to bring the numbers over to one side first and the letters to the opposite. It doesn't matter. Alrighty. So let's start solving some equations. Again, don't forget about the distributive property because it may apply. So distributive property is happening. It's happening on the right. It becomes 6x minus 8. On the left, 5x minus 2. I'm going to bring my letters to the right. No particular reason. That's just my choice. Subtract 5x from both sides. Negative 2 equals x minus 8. If my letters go right, my numbers must go left. And the answer comes out to be 6 equals 8. Again, you can always check your answer to make sure that you are correct. I will do a quick check. You don't need to do it all the time, but I'm going to do a quick check here. It's 5 times x minus 2 equals 3x minus 4. I'm checking with the value of 6. 6 goes here, 6 goes here. On the left-hand side, 30 minus 2. On the right-hand side, 2, 18 minus 4. On the left-hand side, 28. On the right-hand side, 2 times 14. Bring down 28 equal to 28. I know my answer's right. Again, you do not have to show checks for everything, but you're probably better off doing that because you should know if your answer is correct before I ever see your paper. Number 5, two distributive properties. Just be careful because there's a distributive property here and there's a distributive property here. Okay, so on the left-hand side, I'm going to distribute 3x plus 3. Never used minus 5x, never used 12. But now I'm distributing in a negative 1. It's a minus that's going in. This becomes minus 6x plus 7. Notice that you've got like terms on the same side. I've got to combine those before I do anything. So on my left-hand side, I should get negative 2x plus 3. On the right-hand side, I also have like terms. It's here and here. And so my right-hand side, I get 19 minus 6x. I'm going to bring my letters to the left this time. No particular reason. Add 6x. Add 6x. 4x plus 3 equals 19. Letters go left. Numbers without letters go right. Subtract 3 on both sides. 4x equals 16. Divide both sides by 4. And x equals 4. I can do a check if I want. I know that I'm right, so I'm not. Next one, a couple ways to do this. One way, I think the easier of the two ways would be to actually distribute 2/3 into the parentheses because you can. All right, 2/3 actually goes evenly into 6 and into 15. So the idea is that my left-hand side doesn't change, but my right-hand side, 2/3 of 6. One way to think of it as 2/3 times 6 over 1. I can cross cancel here, get a 2, and out comes a 4. I can think about doing math. I can say 6 divided by 3 is 2. 2 times 2 is 4, and there's an x. It doesn't matter what you do. Okay? So I know that 2/3 of 6 becomes 4x. When I do it again, if I want to do math, 15 divided by 3 is 5. 5 times 2 happens to be 10. So somehow I'm losing that fraction. So we get 8x minus 6 equals 4x plus 10. I'm going to bring the letters to the left, subtract 4x, and I'm going to get 4x minus 6 equals 10. Therefore, numbers without letters have to go right. And then I'm going to get 4x equals 16. Divide by 4, x equals 4. I don't know what all the answers are for, but whatever. So that's one way. The other way to do this is to do math from the very beginning. And this way is going to work just fine. I don't know that, this way I don't think is any, I think is probably a little more challenging, but you can. Remember the idea is that we've got denominators, and the denominators really are a 1, and then this 3. How do you get rid of denominators? Well, you multiply everything through by the LCD. If you do that, you do math. 3 divided by 1 is 3 times 8x is 24x minus minus. Excuse me. 3 divided by the second denominator 1 is 3 times 6 becomes minus 18. And now here's where you got to be careful. 3 divided by 3 is 1 times 2 is just 2. But don't forget there's a parenthesis. You're not multiplying the 3 into the parenthesis. You're using the 3 to get rid of the 2/3. What happens here? 24x minus 18, distribute 12x plus 30. Now, these equations do in fact look different, but they're not. They're equivalent expressions. Hopefully, or maybe if you look at it, the black equation, this guy right here, and I'm not sure that you can see it or not, but if I take this whole equation and I multiply every single piece by 3, aren't you going to get this one? It's kind of cool. Let's bring all the letters to the left, subtract 12x, subtract 12x, and I get 12x minus 18 equals 30. If letters go left, numbers go right. And then I get, oopsie, 12x equals 48. Divide by 12, divide by 12, the same answer. That's the whole point. You need to choose which way you like better. Basically, pick your poison, if you will. So then here we've got this activity that basically says, all right, this is different because we're not doing it in class, but each student is given an equation. Without solving, find 2 other people whose equation is the same, will have the same solution as yours. You can use properties, distributive property, adding the same thing on both sides, subtracting, and other methods of solving equations to explain why the 3 equations your group has will have the same solution. Think of it this way. We've got a column 1, we've got a column 2, and we've got a column 3. I'm going to actually letter these in column 1. I'm going to call these guys A, B, C, and D. In column 2, I've got some equivalent equations. As you look down column 2, look at A for a second. Couldn't I distribute A, and wouldn't I come out to this? So that means those are equivalent equations. Let's also now keep with A for a second. Take a look in this case. Look over here at either one of these A's. Look at this one or this one. And look into column 3. Look at this. How could you get there? Some people say, well, I could take this equation right here, divide both sides by 2, and get x minus 5 equals 7. That would work. Some people say I could take this equation, divide everything by 2, and get x minus 5 equals 7. But just understand that those 3 equations are equivalent, and they're going to give you the same answer, but they don't look the same. If you were to look at B, okay, so I'm going to give this letter, I'm going to call this B here. If you looked at column 2, what is the same equation? What's equivalent? Hopefully you're going down here, because by subtracting 2 on both sides, I could get 1/4 x equals 4. Let's take a look at column 3. Hopefully you can see that this would be the same equation. If I were to take this particular equation right here and multiply both sides by 4, I am in fact going to get to this equation here. Let's look at equation C. Put that in black. Column 2. Do you see anything that's the same? It's definitely not this one, because I can't have a -1 and a +1 and say those are equivalent. That's not the same. I can't have a +2 and a -2. Those can't be the same. So basically, that kind of leaves you with the process of elimination and says, well, this must be the same as C. And that should make sense, because if you decide to divide everything by 10, right? If I divide everything by 10, I've got 5/10. I've got -1/10 equals 3/10 plus 2/10. It's just in decimal form, not a big deal. Look over into column 3, and hopefully you realize that this is also the same equation. You might be able to see it better from column 1 though, right? Because all you really have to do is, in this case, if you, what are they doing here? Oh, they're using the commutative property. They're changing the order. Hold on for 1 second. This actually would be, I don't think this is right. I think we've got a mistake here. The idea would be is if you added 1 to both sides, this should really be a +3. So I think that's a mistake on our work, but it should be, that's the one that we were looking for it to be the same as. Okay, so I have to make note of that. Last but not least, what's left, I think that's probably a no-brainer. If this is D, this has to be D, and this has to be D. What's if I go from, I guess, basically from this column to this column, column 1 to column 2, you're basically dividing everything by 2, right? If I divide this by 2, there's my 5x. This by 2, there's the 1. This by 2, and this by 2. Okay, that's what's happening from there to there. What's happening from here to here is actually that you're doing, you're multiplying. I think we have another little bit of an issue. Hold on here. Hold on. Let me take a look and see what's happening. I think there's, I'm going to kind of just pause it on here because I'm trying to figure out, we multiplied just part of that by -1, but not the whole thing. So 10x. So I'm going to kind of pause this on this one. I need to probably go back and take a look at our sheet and see what we did. Anyway, I'm hoping that you at least are getting the idea that you've got equivalent equations by just using different properties, multiplying things by the same number, dividing things by the same number, etc. All right, so that should be enough to be able to get you through your homework. All right, so goodbye, bye.